Have you ever wanted to travel at the speed of light?
Louis, hit the hyperdrive.
Or have no mass whatsoever? Or never have to worry about being late for class? Well, thanks to the Higgs field, you can't. The Higgs field is the field that gives stuff mass. But wait, why do we need something that gives other things mass anyway? Don't things just have mass? Before the Higgs field was theorized, mass was generally thought of as the amount of stuff inside something, but there's a problem with that explanation. So to understand what I mean, let us journey into the subatomic world. This is an electron. Electrons cannot be broken down to anything else, so we call it an elementary particle. Elementary particles are arranged into a table called the Standard Model of Physics, and they are not made from anything else. In particle physics, there's a group of elementary particles called fermions. They all have mass. Electrons are in this group. But if mass is the amount of stuff inside something, how could elementary particles have mass? They are not made from anything else, right? That's why we need a new explanation, and this is where the Higgs field comes in.
Hello.
This is the Higgs boson. Higgs boson is simply an excitation in the Higgs field. That happens when a lot of energy is put into the Higgs field. According to quantum field theory, all elementary particles are simply excitations in their own fields. It's like plucking a violin string. The Higgs boson is a ripple, and the energy is me plucking it. Anyway, as I was saying, the Higgs field is a field that permeates the universe and gives elementary particles their mass. No, not that kind of field, but a field that has a value everywhere in the universe. As elementary particles move through the field, they interact with it. The more they interact with the field, the more mass they are given. This is called the Higgs field, and it was first theorized in 1964 by Peter Higgs and 5 other scientists.
Okay.
Imagine that a top quark was moving through the Higgs field. The top quark, which is the heaviest elementary particle, will interact with the field a lot, therefore receiving a lot of mass as a result. However, if a photon, a massless particle, was to move through the Higgs field, it would not interact with the field at all. Therefore, it will not receive any mass as a result, and that's why it can travel at the speed of light.
I still don't get it.
Let's say that we're in a crowd of high-tech lovers. There's a brand new iPhone X moves through the crowd. Everybody will want to see and interact with it, so it's given a lot of mass by the crowd, which is the Higgs field, just like the top quark. If a Firefly phone moves through the same crowd, nobody wants to see and interact with it because it's not high-tech, therefore it is given no mass, just like the photon.
How do we prove something like this?
Building the Large Hadron Collider. Two groups of protons are made to go really fast in a tube in different directions. When they're traveling fast enough, they're smashed together. This releases a lot of energy and it may excite Higgs field. Sometimes the Higgs boson created, but they decay almost immediately. Also, we need to observe it really fast. 300 trillion collisions were analyzed to find the Higgs boson, and on July 4, 2012, scientists finally confirmed the existence of the Higgs field when we found you. So before you start blaming the Higgs field for not letting you travel across the galaxy at the speed of light with Han Solo, just remember, without the Higgs field, nothing will exist, not even Barney.